In this video, we're going to look at the area of non-right triangles. When dealing with these, what we're going to do is we are going to look at what's given to us. And I kind of introduced this idea of labeling triangles at the end of the law of sine stuff that we did previously, is we need to look at, are we dealing with side, angle, side with what's given? Is angle, angle, side given to us? Or is side, side, side given to us? And what's given determines which formula we use. And to you, it looks like we have a lot of formulas here, but really, if we take a look, they're all the same. And I want you to see that is because I'll give you one formula. It's going to be your job to kind of generate the rest of them. And so if we look, if I want the area in a side angle side situation, we have to realize what's the general structure. I'm going to be taking one half the sides, multiply together the product of the sides times the sine of the angle in between them. So notice I'm going to say all the letters are included for it. It's A, B, C. And so look how this changes between the two formulas. Is in this case, you still have the A, the B, the C. The A, the B, the C is each part is situated. It just depends on which sides you're given and what's the angle in between them for it. And so if I have a side angle side, I'm going to do one half the product of the given sides times the sine of the given angle. And that is what the first situation is going to be. And all the formulas are the same thing. One half the given sides times the sine of the given angle. One half the given sides times the sine of the given angle. So the formulas are all the same. So really it's one formula, and we just write it the three different ways based off of if we're given A, B, C for the sides, or angle A, angle B, angle C. We then have option 2, angle, angle, side. So I'm given two angles and the side next to them. And again, notice 3 formulas. I'm only going to give you one, but the structures are all the same. Is if I'm given 2 angles, we've learned previously with the triangle, if I know 2, I can easily find the third just by doing 180 minus. And so that's why I'm able to do all 3 angles in the formula. Notice this is the side given. A squared is given. So what we're going to do is this. We're given 2 angles and a side. So I'm going to use the side given, and I'm going to multiply by the sine of my 2 angles that are given over the sine of the one I have to find. And we'll go through this along the way. And Heron's formula, which looks really, really, really weird, but this is side, side, side. And when dealing with side, 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 notice the formula, again, going to be given to you. Well, understand A, B, and C are sides in the triangle. S is going to be found by using this formula, 1/2, really the perimeter, side A plus side B plus side C. So 1/2 the perimeter of the triangle is your S. And we plug in and we go from there. So let's at least try a few things. So make more sense of it if we do some examples. When you're given this problem, find the area of triangle ABC if side A is 4.7, side C is 12.4, and angle B is 47. So I know this is 4.7. I know C is 12.4, and I know B is 47 degrees. My first job is to label the triangle with what's given. Draw a picture if it's not there, I have it, but I'm still going to label. I'm then going to label what's given to me. I'm given a side, then an angle next to it, and a side. So this is a side, angle, side situation, which means I'm going to be using one of these option 1 formulas, which is generally the same structure. In this case, I'm going to be using my area is 1/2 A times C. And the reason why I'm using A times C is because those are the 2 sides given. So I'm actually using this part of the formula. 1/2 A times C times the sine of B. So my area is 1/2 4.7 times 12.4 times the sine of the angle in between 47 degrees. And I am writing at an angle, so let's grab that. Let's give myself some room. And there we are. Well, the good news for this is that's all straight order of operations. I don't need side B because I have a formula for side angle side. So what I can do is I can type this in my calculator. So I am going to do 1/2, and I can do parentheses 1/2, parentheses 4.7, parentheses 12.4, the sine of 47 degrees. Just type it all in, straight over operations, and we get 21.31. And so my area for this problem is 21.31, and for area, our units are squared. And that's it. Straight order of operations problem. Our job is to look at what's given to us to figure out what is needed, which formula. So in number 2, which I believe now looking at it as number 13 for you guys, number 2, notice I'm not given a picture. Oh my goodness, draw a picture, draw a picture, draw a picture. If you do not have a picture, draw a picture. So when you're dealing with this, I think I'm going to draw one. So I always like to do A and B on the bottom and C on the top. And so there it is. And so those are my angles, and I'll fill in everything I know. I know side B is 12, so that's right here opposite angle B. Side C opposite angle C is 14, and angle A is 50 degrees. So if I look at what's given to me, it actually looks like I'm given a side, well, I'm given 2 sides, and the angle in between them. So I'm given side, angle, side. Again, it looks like I'm using this option 1 setup. The problem is, which option 1 do I use? So I also like to just look at what angle do I use, because the angle that I'm using is actually going to tell me which setup I have. So in this case, I have angle A. I'm going to use my area is 1/2 the product of the sides given to us, which are B and C, times the sine of the angle given to me. So even though I'm using, if you look at this formula and this formula, I'm using 2 different formulas, they're actually the same. It's half the product of the sides given to you times the angle, the sine of it given to you. So I plug everything in. 1/2, the sides given to me are 12 and 14, times the sine of 50 degrees. So my area is going to be, going to the calculator. I have 1/2, parentheses 12, parentheses 14, sine of 50 degrees. Hit enter, 64.35. So my area is 64.35 units squared. So we label our triangle, figure out what we have, side, angle, side, 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 or angle, angle, side. And it determines which formula we use. In this case, the first 2 we use are the side, angle, sides, option 1. So let's see what happens on the back page. On the back page, these are not new formulas. Just to make it easier so you didn't have to keep flipping back and forth, I put the formulas on the back page of the notes as well. And so we can go through this. The area of triangle DEF, if side D is 13.9, angle D is 34.4, and my apologies, this should have been in capital E. Angle E is 14.8 degrees. So again, I have to draw a picture because one's not given to me. So I'm going to draw a picture, and I don't care about scale. just like ABC triangles, when I deal with this, what I like to do is I like to go alphabetical. So this will be D, this will be E, and then I'll have this be F. I'm going to label what I know. Side D is 13.9. Angle D is 34.4 degrees. Angle E is 14.8 degrees. So the question is, what do I know? Well, I know two angles and a side outside of them. So that's angle, side, which means I'm dealing with, in this case, option 2. Now in option 2, what we're going to do is we are going to find out, we need, no matter which formula I use, I need to know all three angles. So what I'm going to do is I'm at least going to find what my other angle is. You know, what is angle F? So I'm going to do 180 minus 34.4 minus 14.8. And that tells me that angle F is 130.8 degrees. Now I know everything that I have to. And so I'm going to figure out which formula I use, and that's the more complicated part. But the interesting part is, notice no matter what, you only have one side in all the formulas. And in this case, I have one side, and that is side D. So when I do my area formula, area is 1/2. It's the side given squared. So it's going to be D squared. And I'm going to have the sine of some angle on top. I'm going to have sine of another angle on top, and then a sine of an angle on the bottom, following this structure up here in the notes. The question is, which goes where? Where does D go? Where does E go? Where does F go? And it's very simple in this case. Notice when you're dealing with this, you have a side D, it's not the highlighter, you have a side D, you have a side A, and the angle associated with it goes on the bottom. So if I have side D, angle D goes down here. And then it doesn't matter the order, E and F can go up there. So you're going to be given the formulas, but if I don't use the exact letters, it's going to be your job to piece it together. So understand, interpret the setup for it. So now it's just simple plug in everything that you have. So in this case, I know my area is 1/2 parentheses 13.9 parentheses squared. Close the parentheses and you have the open new one, sine of 14.8 degrees times the sine of 130.8 degrees over the sine of 34.4 degrees. And the good news is, though that is a very long and complicated looking formula, that is a straight order of operations setup. So we can go and type it in. Now, my personal opinion is I would start using the alpha y equals. It's going to make your life a lot easier to start typing in fractions, because you can do 1/2. And then I have my 13.9 close parentheses squared. I have another parentheses, and I can actually type in my signs in a parentheses and in a fraction. So I have this sine of 14.8, close parentheses, sine of 130.8. And on the bottom, I have the sine of 34.4. If I look at this, it looks just like what I have written down on the notes. So I can just hit enter, and I get 33.06. So my area is 33.06 units squared. So hopefully you're paying attention with, how do I know what formula I use? And yes, it is a little complicated with it, but you have to look for the pattern in the structure. And so since I was given side D, I know the angle associated with that goes on the bottom. So though it wasn't labeled triangle ABC, I can still piece together what's going on. And that's the trick here. Just like the trick here is you use the angle that's given to you, the sides that are given to you. So let's try number 3. Oh man, no picture. So, oh, I can draw one. So we have ABC, and of course, because it's me, look at that, it's not drawn to scale. Side C is 4, so I'm going to label this 4. Angle A is 37 degrees. Angle B is 69 degrees. So in this case, I have an angle, a side in between it, and an angle. Well, that's not helpful, because if I look above, none of those are angle, side, angle. But if I notice, if I have 2 angles, I could easily find that third angle. If I take 180 minus 69 minus 37, and in that case, I'm going to get 74 degrees. So we'll just enlarge it for a little bit so we can see. So now I do have all my angles. I actually have angle, angle, side. So sometimes you have to just fill in the triangle and see which formula works. And I'll tell you right now, if you're given 2 angles, I mean, look at this. Nope, doesn't work. Nope, doesn't. Hey, there's 2 angles, angle, angle, side. So when you're given 2 angles, you know you can always find that third one, and that creates the angle side. So I'm going to use this formula, and I'm going to kind of cover it up. The general structure of the formula is area 1/2 the side given squared. So the side given was my 4. And then the rest of the structure, I'll give myself some more room. The rest of the structure follows this. You're going to have, and it's in the formula, and I don't need you to have it memorized, but notice I'm not looking at it because I need to know as a student where each one goes. Because I have 3 angles and I have 3 spots. Well, the side given is associated to the angle that's on the bottom in every formula. And that's what I tried to point out last time. Those two are the ones that relate to each other. So I have side 4, so 74 degrees, the angle opposite it, is going to be the one on the bottom. On the top, it really doesn't matter the order because they're being multiplied together and the commutative property works. So there's your general setup, and I am going to type that in my calculator. Now I'm going to have some fun. Let's do this the old school way, the way I did when I was in school, without the alpha y equals helpfulness that I really think you should try and use more often. 1/2 goes into parentheses. Then I'm going to have a 4 parentheses squared. So I'm good on that. And now if I look, I'm going to have a fraction. And so the numerator, so there's a fraction, there's the parentheses for the fraction, but the numerator I'm going to put into parentheses. So sine of 37, I got to close the parentheses. Then I got to type in sine of 69, close parentheses. That's just for closing it for sine. I still have to close it for the numerator, and then divide by sine of 74, close parentheses for that, close the parentheses for the fraction, hit enter, 4.68. Look at how many parentheses that is. So we have 4.68 units squared. And so we're dealing with 4.68 units squared. We are having a very small triangle. But notice why I say I would really start using my alpha y equals. It's simpler to type in, and it looks just like the formula. Sine 37, sine of 69, and on the bottom, sine of 74. And that allows me to hit enter. you get the same thing. I really think this bottom one looks so much nicer to type in than this top one for it. So there's the other one. We got two more. Well, these two are different. It's going to be very hard to draw a triangle in this case. I don't have any angles. Side, side, side. Even in this one, side, side, side. Good news, there's a formula for side, side, side. And you have Heron's formula. Now, this formula looks really, 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 really complicated. Here is what I think you should do first. Just find S first. Because if I know S, it's going to be easier to plug in. So you guys have it written down. I'm zooming in to make it a lot easier to see. S is 1/2 the perimeter. And that's what A plus B plus C means. So S is 1/2 of 4 plus 7 plus 9. If I type that in, I'm going to get 10. There's your S. Now the formula says the area is the square root of your S, which is 10. I'm going to write this down, the whole formula. Parentheses, your S minus your A, so minus 4. And then parentheses, your S minus your B, 7. Parentheses, your S minus your C. I would not type that in my calculator in this way. And the reason why is it's a lot of stuff. What I'm going to do is I'm going to just do the math quickly. 10 minus 4 is 6. 10 minus 7 is 3. 10 minus 9 is 1. And that is what I'm going to type in my calculator. It's going to be a lot easier to type this in than it is to type that in. So this is really going to be the area is the square root, and I'm just going to do the math of 180. If I type the square root of 180 in my calculator, I get 13.4 units squared. So Heron's formula, though it's weird looking, find S first. And then don't rely on the calculator at this point. I mean, guys, you can subtract 4, you can subtract 7, you can subtract 9. That's not hard. Use this. If you want to type this in your calculator, okay. Personally, I don't think it's hard to multiply a number by 10. So I'm going to use that. Let's do one last one. Again, I already labeled it side, side, side. That tells me Heron's formula. So your side is 1/2 the perimeter. So 1/2 the side A plus side B plus side C. If I type this in, I get 57.5. So my area, if you're one of the people who wants to learn less writing, you want to be lazy like me, you will type in, well, you got 57.4 for your S. What I'll do is just this. Right on the bottom here, I will do my S minus my A. So I'll write this down underneath, and I'll just write down 33.5. And then I have the next one, which is your S minus your B. So 57.5 minus 52, which in this case is 5.5. So I'm still doing the same formula. I'm just finding a way to kind of combine some steps together if I need to involve less writing. So then on this one, I'm going to do my S, 57.5, minus my C, which is 39. And I get 18.5. Now, my mental math is pretty good, but I'm not going to multiply these numbers together. I am just going to type that directly in my calculator. The square root of 57.5 parentheses 33.5. Put another parentheses 5.5. Close it. Put another parentheses 18.5. I'm just going to type it in. Now my mental math is good, so I knew it was 442.71. So it's 442.71 units squared. So your job is to first determine which formula I'm going to use based off of what's given to you. And then from there, you plug everything in. What you need to be doing when you're going through the homework is first doing that, determine whether it's side, angle, side, or side, and then finding the pattern in the formulas. Where does each thing go? So there is the lesson dealing with area of non-right triangles. Take the rest of class time and work on the assignment as well as the review.